Hey everyone, I'm Tejas. I'm an engineer at Segment, and I'm going to be talking about gRPC today. So I'm Tejas Manohar. As I said, I'm an engineer at Segment. Segment's basically a company where we are a hub for all your customer data. So you can send customer data through us from your apps, and we can forward it to a bunch of analytics tools and help you get a picture of what your customers are doing in your app and how you can improve their experience. I'm at Tejas Manohar at GitHub, Twitter, and like all social media. So if you want to reach out to me, that's how. So what are we talking about today? I mentioned we're talking about gRPC. So first we're going to be talking about what gRPC is. Then we're going to go into why gRPC. This is going to be the bulk of the talk. Basically, we're going to talk about what problem gRPC solved for us at Segment, why we got started with it, and why it's really cool. And next, we're going to be talking about how to actually use gRPC. And in this part of the talk, I will give a quick demo of using gRPC with Node.js, just showing some like real code that we actually use to use gRPC. So yeah, first, what's gRPC? So gRPC is an RPC protocol. Basically, what RPC means is it's remote procedure call. What that means is that you can call a function defined on another service by just executing a function, and the implementation details are kind of abstracted away in the protocol. So usually when you want to call a function defined on another service over a network, you use something like an HTTP API with maybe a REST style parameters, and you use JSON to pass around the data between them. RPC is like that, except instead of writing client wrappers and focusing on these implementation details, the protocol is all defined, and you just focus on the functions that are declared on the other server and how to call them from your client. So gRPC is powered by Protobuf. Protobuf is a serialization format. What I mean by this is it's comparable to JSON or XML. The difference between JSON and XML and Protobuf is actually a binary format. This means that it's way faster to read out of, and its user experience is actually better in my opinion because it has a type schema. You can't actually read the Protobuf encoding like you can with JSON or XML or YAML, so it's definitely not good for configuration or anything like that. But it has a type schema, which what I mean by this is you can't like misspell a field in your Protobuf or anything like that, because they're basically composed of structures that have fixed fields and types. So you just have to, you don't have to worry about passing around strings or something like that. Lastly, gRPC doesn't just power servers and clients, it actually is an API client generator. So basically, when you want to use an HTTP API, you usually write some sort of wrapper around it so that you can just call functions around your code rather than using something like the request module around it. With gRPC itself actually takes the Protobuf spec you write and generates client wrappers so that you don't have to do that manual work and keep it up to date by yourself. And it does this for Node, Java, Go, and tons of other languages. So you're pretty much set there if you have a lot of clients. So basically with gRPC, we don't have like the basic argument of put versus patch in HTTP. We just think about functions. That's the main building block in gRPC, and nothing else. You just worry about, like, if there's a login function, you don't have to worry about, will it return a 200 status code when there's an error. You could just have an error field and return that. So this is how it works if you're actually building a service with gRPC. So first off, you define your API in Protobuf, which is the encoding language I talked about earlier. So you just write out a spec for what methods you're going to have in your service and what they're going to take in and what they're going to respond. In this example, you'll see that we have a set method which takes in a set request and returns a status response. The set request is a struct that's defined right underneath, and it has 3 fields, a collection that's a string, an ID that's a string, and some loose bytes, which are properties. This is hard-coded. You can't like misspell fields or anything like that. You're satisfying this interface, and your client will be generated based on this. So given this Protobuf, you can actually give this to gRPC, and it can generate clients in practically any popular language. So in this example, it's generating a Go client, just because it's typed, so it's easier to get the point here. But it generates a struct for the set request input, and then it generates an actual function that you can call, which will actually make the network call to another server that's using gRPC. So what gRPC is not. Before we get into what gRPC is and how you can use it, I think it's pretty important to talk about what it's not, just to set things clear. So first, it's not a monolithic framework. It doesn't replace something like Sails, Happy, or Rails. And it's also not as low level as something like Express, Restify, or Koa. And That's also why I say that it's not a standard library. It's very opinionated. It doesn't really give you any control over the networking or how you actually make these requests. It's very high level, and you just focus on calling functions, and it handles all the implementation details. So before we get into how to use gRPC, I really want to focus on the problem and what gRPC actually solved for us at Segment and why we started looking at it in the first place, because that shows how cool it is. So Segment is the place that I work at, and it's basically started off as a data router. So in your app, you would write some code snippets to track events that your users are taking when they do something. So in this example, when a user clicks a link, you write the small code snippet to track an event that sends the user ID along in the referral code of that link, and an event that says that they clicked the link. This event would then get forwarded to whatever integrations you've set up in the Segment UI. Basically, you can send it to things like Google Analytics, Mixpanel, Intercom, HubSpot, etc. without changing your code at all. All you have to do is focus on getting that event to Segment with our libraries. But we realized that the data in your app is not really all the data about your customers that you want to analyze. It doesn't really tell the full customer story. So we started working on sources, and that's where gRPC comes in. So sources is basically a product where we pull data from tools like Twilio, Zendesk, Salesforce, Stripe, Intercom, and bring that data into the Segment pipeline so it can go down to your integrations and your warehouses. So we realized that since all the data about your customers is on your app, we introduced these third-party tools too. So basically how sources is architected is we have a source executable, which is basically a program that you write that takes in some command-like arguments with the customer's credentials for this third-party tool and things like that. And this program is run through our infrastructure periodically. So customers will pay us for a sync frequency. So say they're on like the free tier plan, their Zendesk source, which pulls data from Zendesk's API and pushes it through Segment's pipeline, will run once a day. And the scripts are supposed to be very simple. We're just supposed to make the developers of the sources focus on pulling data from the third-party API and nothing else. But at Segment, we have microservices, which basically means we have a different service for each thing that the source needs to do. For example, if the source wants to write an error to the customer or send a message to the customer, like their credentials are wrong or something like this, they have to use the report service. If they want to send data from this third-party tool to Segment's platform and to Segment's pipeline, they use the Objects API service. If they want to set some context that they can read in the next source run, they use something called the context service. But basically, we have all these different Segment tools that we realized building a source isn't as easy as just reading data from a third-party tool. And we wanted to make it that way. So as a result, we started building abstractions. So what's the ideal thing that you do when you want to make something simpler and hide the implementation details? You write a library, right? So in this case, we followed the inspiration of LeftPad as a joke, and we built a library that basically was called Node Source, and it would allow us to send data to all the places sources need to go. For example, as I mentioned in the previous slide, report service, Objects API, context service, and everything else. This worked at first, but then we realized not everyone likes JS. So we had built a ton of integrations. Like on our integrations platform, we have over 200 integrations like Google Analytics, Mixpanel, etc. But that was a lot of maintenance burden, and we wanted to make sure that when we built sources, we could actually let partners develop sources for us. And we didn't want to constrain them to like Node or another platform. We wanted to be as easy as possible. So at Segment, our idea was, OK, we'll build more libraries in a bunch of different languages, because that's what we've done with previously, because that's what we've done with our Analytics API, where customers can send us events from their app. We have like 15 different libraries in a ton of different languages. But we realized that this was a big maintenance burden. Like we have people fixing bugs in these libraries all the time. We have people asking for more features in them. Some people don't like the style that the libraries are written in, and they don't really fit well with their code, et cetera. And we didn't want to take on this maintenance burden. We wanted to be a lot simpler, and we wanted to be able to scale it up too. So currently with sources, just to give you an idea, we're using Python, Node, and Go. These reasons are because things like the Google AdWords API, which we use, has a Python client, and it's a very complex SOAP API, and we don't really want to take on the hassle of maintaining a client in another language. So what we decided to do to avoid writing a bunch of libraries in different languages, because writing libraries for each of these services we need to interact with in all these languages and potentially more is not easy to keep up to date, we decided to build this service called Source Runner, which basically is an RPC service that sits above the source, and it handles all segment-related functions. That means like sending data to the segment pipeline, managing context between runs, publishing reports to customer-facing UIs, and so forth. It also runs sources as a child process of it, so that when you run the source, it actually runs Source Runner, which runs the source, and exposes a server which the source talks to. This means that we could just write a very simple library in each of the languages and not have to worry about and this library would just do one thing specific for the source, not like the APIs that power multiple things at segment in our microservices. So at first, Source Runner actually wasn't using gRPC. It was using JSON RPC over HTTP. This is how it looked like. Basically, you would have Source Runner, which would run the source. The source would be responsible for talking to Zendesk API or MailChimp or whatever. And so the source would just use simple declarative calls like the word set or get context or things like this. And the Source Runner would proxy through all the segment services, and the source wouldn't have to worry about this. What this also meant is that we could write a little mock version of Source Runner, which we actually have, for development, and we could hand this mock version of Source Runner to our partners, and they could develop sources and just see mock data locally with all the segment services, rather than being in our infrastructure to develop the sources. So this was really effective at first. The good parts was that it was really, really easy to write sources. We also got free things because we had this generic piece of infrastructure, like safety checks. We had timeouts so that if the sources were running too long, we would kill them, keep alive, things like this. We also had free monitoring. The Source Runner acted as a proxy and took metrics on all the different API calls the sources were using. But Source Runner wasn't really perfect. So the bad part about Source Runner was that we had a ton of small libraries that we had to manually update. We basically had libraries in Python, Go, and Node, as I mentioned. And these languages still had multiple paradigms. Some of them use threads, some of them use promises, callbacks, etc. And different developers wanted to do different things, and we just didn't want to put up with the maintenance burden of this. In addition, Source Runner wasn't performing as we would hope. Basically, HTTP requests are not that cheap, especially when you're opening and closing a lot of connections with small ones. Node.js connection pooling, at least in 0.10 versions, was kind of a mess. We ended up getting really terrible networking errors, and there were just a bunch of different quirks of the implementations of these things in different languages that we knew wouldn't be scalable to maintain as we added like 10 or 15 or 20 more languages to the platform. So we decided to move to TCP. So basically, TCP is the thing that is underneath HTTP. But instead of making like a TCP connection every time we make a request, we moved to WebSockets, which sits on top of TCP. This allows us to stream data from the source to the Source Runner through one TCP connection. So we can send a bunch of different commands over this one connection. It was very fast. It had very little overhead. And the kind of data that we're sending would be like gigabytes, terabytes of objects from the Zendesk API. Basically, like for a customer like Uber, that would be all their Zendesk tickets. So the performance of how expensive like one of these commands to send over the wire is actually kind of matters. So the bad part about TCP and our new Source Runner in general was that WebSockets has a ton of different specs. And when you're supporting a ton of different languages, we run into, once again, the same problem, which is that we write something in one language, the server is supposed to send signal X when it's closing in one language, and then the client in another language expects a different signal. Basically, these things are not so well defined, and different languages had different semantics. It was still not maintainable. There was also no request and response abstraction in TCP, so we had to kind of make that up ourselves. This just wasn't ideal. So now the question we asked was, what's performant and easy? And we realized it was gRPC. So after a lot of searching, we were looking for, what can we pick up that can handle all the maintenance burden of adding a bunch of languages for us and still keep it performant? And that was gRPC. So we had a bunch of wrappers like Go source, Node source, Python source, etc. And these all went away when we basically used gRPC, or they just became generated code. And I'll show you what I mean with that now. So the good things about gRPC is that all the data is multiplexed over a single TCP connection. This is just like what we had with WebSockets, except gRPC handles a bunch of the networking errors for us. It has things like retries, reconnects, it's resilient, etc. In addition, gRPC has already made request and response abstractions. All you have to think about is functions. And that's pretty much what we wanted the whole time but could never find. So now I'm going to show you guys what gRPC actually looks like and how you would build an app in it. So basically what we have here is a client that is actually a client to source runner that I talked about earlier. It's not a real source, of course, as you can see. It's just setting some garbage data to the source runner. I'm just going to walk through this step by step first. So first, we import the gRPC module. Then we tell it where our proto file actually is. And as I mentioned earlier, the proto file is what defines the schema of our API. So here we say that we have a service called source. The service has an RPC method called set. It takes in a set request and returns a status response. The status response really just is error handling. The set request tells us what kind of data we want to set to the segment pipeline. So like what kind of table does this data belong to, or collection, what's the ID of it, and what are the properties. One caveat here we really hit with gRPC, which if you were to adopt it yourself, you'll probably hit as well. Because it's typed, it's very hard to add freeform data. And we couldn't account for every single possibility of what fields would be in a sources object payload that comes through, like what properties actually come. Properties could be something like the email of the author of a Zendesk ticket or the name of somebody in a Salesforce lead. So we decided to send JSON over this payload, which is kind of an anti-pattern, but also the only really way to do things in gRPC at the moment, because the maps only support one type, which is like you have to have a map of string to string or a map of number to number or something like that. And we needed to support many types. So basically how this program works is we tell Node where the proto file lives, which is over here in the domain folder. And then we create a client. So there are two ways with Node to actually, so with Node, there are actually two ways to make a gRPC client. So one of them is generating code. This is a new thing that I haven't explored too much with Node because it didn't exist when I used gRPC. And then the other thing is that it actually builds the client dynamically after parsing the protobuf. So that's what we're doing here. So basically when you do create client, you pass it a URL where the server actually lives and the path to the protobuf file, and it builds a client on the fly. That client has all the functions defined that are actually in the protobuf file. So in this example, it has a set function defined, and it can take an object with all those properties. Because Node's untyped, we don't really get the benefit of having like validation that we're calling the right properties, unfortunately. But if you were to use a language like Java or Go or something like that, these arguments are actually typed. So with TypeScript, there's actually an extension where you can get these benefits. Then you just make that call. It makes a network call. It returns an error and a response. In this case, we just log those out. But in the source's case, they may do something based on that. And yeah, that's the gist of it. So if I'm to give this a shot here, basically, whoa, is this visible? OK, so if you run the source here, which basically just runs source runner with some arguments that we have to pass to it, and then that runs the Node app, you'll see that source runner, that the Node app connects to source runner. It makes a set call, and then source runner actually receives this call and prints out the value. This is what I meant earlier by we could write a mock interface using source runner. So that's actually what's running here. So we didn't have to like implement the same API twice or anything like that. gRPC actually generated the stubs, and we just had to fill in the functions. So yeah, it's pretty slick. So the next question is, like, what's next for gRPC? Should you go ahead and use it for all your services? What are the trade-offs of using it? So first thing, the Node client on gRPC is not the best, frankly. I think TypeScript has a lot of potential with gRPC because one of the big advantages is type safety. There was a proposal for gRPC and TypeScript. It's still open, and there has been a prototype that looks pretty good. I've yet to try it, but I would definitely encourage you guys to try it if anyone tries it out. Also, front-end support. So gRPC is really great if you have a lot of microservices on the back end, but it doesn't support front-end web right now due to just like the semantics of the network calls. But there is a prototype out. There's one unofficial one, and then there's also one by Google itself, who owns gRPC. And there's a spec that they've put out on how they want to implement this. Interoperability is the other thing. Like if you're using some services that only support JSON, sometimes you may want to convert back and forth between JSON and the protobuf format. There is a package out by Google called gRPC Gateway that can actually do this. And then the last thing, and the reason that we don't actually use gRPC for all our services at Segment, is networking. So gRPC doesn't have any really renowned load balancers. It does have one by Lyft, which uses gRPC. And what I mean by this is you can use any load balancer that supports TCP, but in order to use one that gives you benefits of like actually taking metrics on the request data that's coming through, you have to use something that understands the protocol. And not very many things understand gRPC right now, and definitely none of the Amazon hosted ones. So you're kind of on your own at this point, but I think it's something that has a lot of potential. So these are all the companies that use gRPC and are somewhat renowned for it, like I've written posts about it or something like that. So you're definitely in good company if you try it out, because a lot of people are investing in this infrastructure. And yeah, with this kind of community, there's really endless possibilities with gRPC. We just need a ton of open source projects around it. So yeah, if you're interested in working at, on problems like this, with distributed systems or building data pipelines, or you're trying out new technologies like gRPC, come talk to me, because we're definitely hiring a lot at Segment. And I'll leave the rest for questions. Does anyone have any questions about gRPC? OK.
So stuffing JSON into gRPC. Any thoughts of going away from that, or how you'd solve that in the future, or normalize that across other APIs?
So I think one alternative would be that the source registers a schema with the source runner and gives it some sort of protobuf schema, and then we use reflection or something like that to pass protobuf encoding over the wire. We haven't looked into this yet, because what we're doing works pretty well, but we definitely have run into some caveats of JSON, like numbers, for example. You just have a number type. One of the advantages of using something like gRPC is we can actually tell if you're sending us an integer or a float, but JavaScript and JSON don't really support that. But yeah, I don't have any other ideas on that right now. The other option is like coercing things into a string and then telling the server like what type you're actually sending, but that doesn't sound so great either.
So you're more interested in the data you're transmitting to yourself, not the contents of the data, right? If you were more interested in the integrity of the contents of the data, would you approach it differently?
We are interested in the integrity of the contents of the data, but the number distinction doesn't matter as much to us right now. For example, like our front-end tracking API is also written in Node. So we have had a couple of complaints about number types not being coerced exactly as expected. It's something we're planning to solve eventually, but it's not something that we have yet. So.
Brendan keeps promising us better numbers.
It's probably a long while.
Right.
Any other questions?
You mentioned streaming responses. What's that?
So basically what I mean by this is gRPC has a couple different ways you can send requests and responses. It's all over one TCP connection. First thing, you can send like just a normal request one way. You can also have two-way requests, so the client can actually listen for data that's coming from the server, so you can make something kind of like pub sub over gRPC. That's basically what I meant about streaming. You don't like open a connection or manage a pool or anything like that. You just send a bunch of commands. It's like multiplexing over one connection.
Can the server send a response that keeps streaming?
Yeah, the server can send response that keeps streaming. And the client, in the Node client, you can actually like have a stream off of that. So.
That's super cool.
Yeah. I mean, it's not that cool that you can do this in general. It's just cool that you can do it without writing a bunch of code to power that. So. Cool. Any other questions? Hey.
What is the goal to use service messages instead of function?
What'd you say?
So you used services, messages instead of functions. In your demo, what is the goal of this?
The server basically exposes functions, but were you talking about the messages in the proto file?
Right.
Okay. Those were like input and output. So they're basically objects that you can take in and out of the server. So the messages model the request and response format. Does that make sense?
Yeah, makes sense. What do you use just a function?
Oh, I think the reason gRPC chose like sending messages in and out of the server rather than just adding the types there is probably something to do with interop in different languages, I'm guessing, but I'm not sure.
Okay, thank you.
Great.
Hi, my name is Nick. I was just curious to know, based on the story you told at your company segment, you talked about a situation where you were trying to work with a lot of other providers and APIs, and that somehow you arrived at gRPC as sort of a solution that helps simplify supporting other code bases like Java or Go or Python. So how did, in the end, has gRPC simplified your life as developers?
Yeah, so it's been about a year with gRPC at Segment, actually a little over a year now. It's been quite well. So basically, we can hand Source Runner to a partner, and they can build a client to it without worrying about any of the implementation details, as long as it fits that protocol. We can also really quickly onboard developers to work with all these services, because all they have to do is think about functions really, and not like the different protocols that they use. In addition, we don't really have any language constraints, which is nice. Of course, we try to build our own stuff in consistent languages, but we're able to support other people building things in any language without additional effort on our time. So comparatively, we haven't really found any bugs in our clients for Python and Go for this API, but in our clients for our tracking API, which takes in events from customers' apps, we've had to sort out a variety of problems, because they're also fairly complex. They have batching and streaming and things like this too. So it's been pretty good.
Thanks, Tejas.
Thanks.